All right. Can you guys hear me all right? Yeah? Okay, good. Are you guys ready to get some serverless on? Yeah? Who's got mimosas? Have they spread out? I sent a request for mimosa. I think one's working its way towards me. Oh, hey, thanks. All right, cool. All right, cool. Thanks for mimosas. All right, cool. So serverless. Who's just for curiosity, like who's done anything with serverless? Has heard of it? Let's start with like who's actually written some serverless stuff and deliver it in dev, production, whatever. It doesn't matter. But few, okay. Who's kind of familiar with the term serverless? Has heard it before? Okay. Who's like other people have been like mentioning the word serverless to you and you're like anxious about it? You're like, this sounds bad. This is like the cloud. This is gonna be bad. Okay, cool. This is a safe space, so feel free to shout out any questions. We'll kind of get into this, but really I'm trying to think about how does this really change. Serverless is coming up, and I'll make some arguments about this as we go, and I'll help set the definition of what it is. But we're wanting to like unpack the idea of it, and figure out the security ramifications. I have a serverless app that I've built that we'll kind of walk through a few screenshots of it, and you can see it on GitHub. And it's pretty simple, but it kind of shows you kind of the direction of how you can do some of this stuff. All right, so who am I? I work at, I'm the head of research over at Signal Sciences, along with my good friend and co-partner over there. I'm an author at lynda.com, that's Ernest over there. And for a training course on DevOps fundamentals, and it's releasing November 8th. So we filmed it back this summer. And we're really excited about that coming out. And so hopefully that'll be good. You can follow along on the agileadmin.com, and we'll be posting out stuff for it. And as we get like free links to it or things like that, we'll be putting it out there as well. I also wrote this little white paper / book that some of the stuff from this talk is pulled from, but that's more thinking about DevOps specifically. And there's some corollaries there, and there's some other ones that aren't. But if you're interested in that, you can go there, you'll get the PDF, and our marketing team won't bother you or anything like that. All right, so, and yeah, here's a quick slide. So I work at Signal Sciences. We're like a web application firewall for modern workloads. We're cloud native, DevOps friendly. We kind of go in either on AppSec or DevOps teams that bring us in. And we try to answer the two basic questions, like, am I being attacked right now? And are attackers being successful at all? And we're hiring if you do any Go or AppSec or DevOps type stuff. And we have a really fun office in Venice. And we kind of put metrics and data and graphs on all the kind of stuff that used to be just buried in kind of like web app firewall, logs or these like big scrolling screens. Oh yeah, I also wanted to give you guys a conclusion up front. That way, if you're like, this is like not the talk that I want to be in, like you know now, right? And so if you stay and you're 15, 20 minutes in, fair warning, I had already warned you what we're going to talk about. So. We're going to get to serverless encourages, this is a definition we're going to end up developing, but serverless encourages functions as deploy units. It's going to be coupled tightly with third-party services, or not tightly, but coupled with third-party services that allow running end-to-end applications without worrying about system operation. We're also going to talk about how the patterns for serverless are emerging. They're not perfect. We're going to talk about doing security with serverless is easier, and we're going to talk how doing security with serverless is harder. We're going to talk about 4 areas that apply to serverless security. Software supply chain security, delivery pipeline security, data flow security, and attack detection. All right, well, let's dive in. What is serverless? We all kind of talked about it. Like what providers are people using for serverless if you're using it? Amazon? Anybody using anything not Amazon? I think Amazon provided the mimosas, so it's very fitting. So that's good. Yeah, so Amazon, and everybody usually thinks of serverless as Lambda. We'll get more into that later. So, we've tried to bring this talk together to lay out all this stuff here. So let's start with a few like misconceptions that people normally have. I think that people hear the term serverless and they hear it and it's not familiar to them and they don't understand what it is. And these are some of the things that they end up thinking. Some feel that serverless is just kind of a rebranding effort by marketing. These are the same people that told you cloud was a rebranding of virtualization, right? They were like, yeah, whatever, we've had cloud since 1987, whatever, right? And you're like, okay. Yeah, so we'll come back to that one in a second. Sometimes people think that serverless means I don't have any servers, right? And then it's like, and now you're kind of asking yourself, like, are these people like stupid? Do you think like, what do you mean serverless, right? You know, and really it's just, we're not saying the people that are pro serverless, like myself, yes, there are servers. You know, we know this, right? But it's that I don't manage them. I don't feed them. I don't care for them. They're not my function of concern. It's not something that I really worry about. I mentioned this earlier that some people think that cloud is just kind of a remarketing of serverless. But you know, this is like not the same as like I just don't have a data center. This is like I'm not managing kind of those instant compute nodes that we talked about earlier. Another popular thing of serverless, and people started thinking about this in the mobile space, is like serverless is just backend as a service. So you start looking at all those data pieces that Amazon or different cloud providers provide, and you say, well, okay, I'm just managing all these kind of like APIs and things like that. I think that kind of fits in the story of serverless, but that's not the thing that everybody's really excited about right now. Also, people like to say, okay, PaaS, serverless is just like rebranded PaaS, right? It's just platform as a service, and now that's what we call it. And I get that argument, and I could make that argument myself a little bit, but I think we see some major differences. Like platform as a service is generally always on. Platform as a service doesn't generally auto scale. So it's kind of rough. And then Adrian Cockcroft kind of drives this point home. He's the of Netflix fame, and now he's over at Amazon as a VP over there on their cloud product. But he says, if your PaaS can effectively start instances in 20 milliseconds and run for half a second, then you can call it serverless, right? And he's kind of like throwing down with all the PaaS folks. All right, well, so you're like, thanks, dude, for telling me everything that serverless is not. Okay, what can we actually use to call this as serverless? There's a really excellent article on martinfowler.com, and if you're not familiar with martinfowler.com, I suggest check it out. Martin Fowler produces lots of great literature, like even like the continuous delivery books and a lot of other developer literature. And usually, like, he's right about a lot of the stuff that's coming up, and we've seen it happen year over year. This article on serverless on martinfowler.com was written by Mike Roberts. So give him a tweet, give him a shout out, and tell him thanks, because the next few slides kind of like reference a lot of the work that he put in there. So in this article, like, there's two definitions that he puts forward. I disagree kind of with one of them, but this is the first one. It's essentially saying backend as a service. Serverless as a term, it first arose in 2012. There was some usage of it to describe doing continuous integration in the cloud. People were kind of talking about it doing mobile. I don't really care for this. This is not what I see when I think of serverless. But this is the definition too that Mike lays forward in this article, and this is really describing the core of function as a service. It's a relatively young space, but it's basically containers running for limited times of execution, and executing the code and returning back to you. Here's a quick history. So in 2012, they talked about backend as a service using continuous integration using third parties. Amazon launched Lambda late 2014, and people started to get it. And in July 2015, Amazon released the API gateway. And so once you're looking at that, people are like, oh, I could like hook this. I could hook this my Lambda up to my web service, and I can start responding to those calls. Because previously, all the Lambda stuff was like, well, you have all these batch process jobs. You want to like resize images, or you want to do kind of like event-based work. Well, now your events can actually be launched out of your API. Oh, hey, thanks. 2 mimosas. This is great. I better get working on the first one here. Yeah. Okay, so what does all this mean practically? Like, okay, here's a traditional setup. Traditional 3-tier. This is not really the way it works anymore, but you could sort of think of like you have your client on the outside coming in through your load balancing proxy tier or whatever. A number of servers horizontally serving that with kind of a data tier at the back end, right? Now your client is kind of talking to the auth service, the API gateway, the web delivery, and it's going horizontally across the front. Your API gateway is now fronting all these functions. that it can serve out. There's also a database server, which I didn't draw lines in here because you could draw lines like to every single direction. But in some of these services, like through Amazon, they have some safe ways you can have the client talk directly to the database service through kind of like a sanitized way for like search, and then kind of your functions and things like that can do like edits and changes to your data services. Patrick Dubois, this is the guy who coined the term DevOps, who we all know and love. He's also talking about serverless a bit now, and he did this little online poll to figure out what makes serverless different for you, what makes serverless good for you, how do you think about it? A lot of respondents are saying you don't worry about servers, you have per request billing, but really everybody started really rallying around the idea of functions as a deploy unit. I think that's really notable. I think that's something that we want to really add in our definition. If you remember for conclusion, that's kind of what we're going to be pulling in here. So how do we kind of pull this all together and say, what do we think serverless really is? Serverless is function as a service. Like Lambda, Google Cloud Functions, Azure has a function service. And you may be thinking, but wait about, what about those things called containers? I love those things. Those are great. That's the cool thing. And I think you can make an argument that container equals a single process, and so therefore you have functions as a service. But so from that view, when containers, they're done right, they're just isolated processes, right? That's the argument you would make. I still think that like we're investing in containers in a way that's more about orchestration. We're sort of still treating containers where they're like more full systems, and so even though like that's our belief, or you can make that argument that that's function as a service, I don't really believe it is. I kind of have a maybe an unpopular opinion on this. So I think like containers, like I think you could also call this serverless like containers on demand. You know, if we were back in 2004, that's totally how it would have been rebranded. You wouldn't have said serverless. You would have just been like, yeah, it's containers on demand, and IBM would have been like, we'll take that. Thanks. That was good. All right. I was worried that my jokes were going to be really bad, so this is the right crowd for me. But the last time I gave this presentation, no one laughed. I was like, dang it. So, and serverless is the no management of servers. Serverless is serviceful, so you are using a lot of those backend as a service things. And serverless is an opinionated framework for compute. It helps you kind of wrap around those pieces, those functions as units. And serverless encourages functions as deploying units coupled with third-party services that allow running end-to-end applications without worrying about system operation. So that's my proposal. I say like we just like take this, we use this as our definition, and we go forward. Who's with me? Drink from your mimosas. You like that idea? All right, cool. Or your coffee or a Diet Coke or whatever you're on right now. Cool. All right, so man, I got a great idea. Let's talk about cloud. Why would we do that? Well, we just had a working definition of serverless. Why not? Let's just walk a little bit further down the path of where we've come from. So I mentioned I had kind of an unpopular opinion. Here's where it will come through. You know, speaking of history of stuff, you remember like 10 years ago, if that would have happened, it's like presentation over. Like it's like you'd be like searching projectors. We've come a long way. Like good job, IT and Apple and stuff. So cool. All right, so let's talk virtualization. Everybody was really stoked about virtualization 10, 12 years ago. Everybody had a virtualization strategy, right? Like that's what everybody had. And then this thing came out and it was like, ooh, the cloud. Well, that's cute. I think that you should, startups should probably use that. You could do like these really small little workloads on it, and it's kind of this, it's this thing that we all laughed to ourselves at the people doing cloud back in 2008, 2009, 2007. That was something that's not really enterprise grade, And does everybody remember that? You remember kind of those words? You're like, I was saying that 2 years ago, 1 year ago. So your boss might still be saying that now. You might need to tell him something. But and somewhere in the middle, this weird thing happened. We started kind of rallying around like delivery of our software, and we started calling it DevOps. And we started thinking like, how do we make this a real thing? And there was a lot of talks about like how often we deploy to production and like the cadence of delivering value to our customers. And we these aren't in vogue to use anymore, right? But like at the time when we were wrestling with cloud and what it means, we were talking about SaaS and PaaS and which is software as a service, platform as a service, and infrastructure as a service. And then companies started coming out as private cloud. And I mean, I'm really not a fan of private cloud, but I think it was the sign that virtualization had lost. Once virtualization had to say, we got this thing called private cloud, and we're going to adopt that as the nomenclature for that old thing that we used to offer, because like the cloud is effectively eating our lunch and taking everything, taking all the market with us. And so really, you know, cloud is kind of an opinionated virtualization run by someone else with an API in front of it that like helps you do all this stuff. And that's what people rallied around, and people wanted that opinionated framework for compute. So then we have this thing now that like containers, and everybody's like, yeah, we have a container strategy, right? Does that sound familiar? Is everybody which company who works for a company that's not interested in containers right now? Yeah, no hands, right? And you're like, and we all took this approach that like that's the way we have to go. A lot of money is being spent, just like we spent kind of in OpenStack and this private cloud idea and trying to make virtualization cloudified or whatever inside your infrastructure. We're doing the same thing with containers now. Like we're spending a ton of money on orchestration. Oh yeah, this is one of my funny slides. There we go. But you know, we've put all this money into it, and I think we're going to actually see that the cloud was to virtualization as serverless will be to containers. I'll let that sink in for a second, because you know we have these right now. Everybody in serverless. We're going to talk about some workloads that people are doing, but everybody sees it as kind of this cute thing that's like this one-off thing that now we do. But for me, it feels so much like where we were, you know, 8 or 9 years ago, or I guess now it's almost 10 years ago, where we were with the cloud, where we're thinking about that. There's a great article by Cloud Opinion, who also kind of shares the same belief about containers and cloud and how serverless is kind of upsetting containers. If you want to lead your company bravely into the new world, you would do well to focus a lot on how serverless will evolve. And so let's go back to our definition. And let's remember like what we're actually trying to do here, right? We're running this end-to-end application. So there's a lot of upsides to serverless. What are they? Okay, I'll stop kind of my little rant about that stuff. But what are the upsides of serverless? Okay, we have scaling built in. In the cloud, you probably wrote some scaling algorithms, but usually whenever you try to do that, like if you started seeing peaks in traffic, you know, your scaling algorithm to really get invoked, spin up new instances and start handling traffic, that could be anywhere from like 3 to 5 minutes, depending on kind of your application and your stack and all that business. With serverless, this is not really true. Everything's built to be concurrent up front, and so that option is taken away from you. And I think it's concurrent up to 1,000 up front by Amazon default limits, and you can get that raised if you want. You're also paying for what you use, and you pay for it in 100 millisecond increments. And so your function not running for, it's not running all the time, so you're only paying when people are actually interacting with, or actually using your code, which feels pretty good. With serverless, the system administration is more or less over, right? We're moving away from like Chef and Ansible, Docker, Shell scripts, and now you still have like more complicated things where you're like mapping all your serverless functions together, all the things they call, but you're not worrying about OS and packaging and some of those versioning problems that you've always kind of been dealing with in the past, right? You do have some new problems with serverless, and we'll talk about that later. There's some other problems like there's like monitoring, logging performance. You still got to figure out how to do all that stuff. There's not like a new relic for serverless at the moment. There's like Datadog has some hooks for it, but you don't really have as deep of inspection as you would want. So, anyways, we'll talk more. Like that's some of the problems out of it. But I can't think of a way to do serverless without doing microservices, which is good because you probably also have a microservices strategy, or somebody in your company is like interested in the word microservices. I think another thing that's interesting, like it short circuits ops and moves infrastructure runtime closer to the developers. I think this is good and bad. I mean, this is what we always wanted to do with DevOps, but like if anybody's had experience with Chef, Puppet, Ansible, like you still end up having like your core knowledge domain set around the people that know how to do Chef, Puppet, Ansible. You do have a little more hooks, like to where like anybody can inspect the code, and it's not. It is like different than like where we were, 10 years ago, where it's like, more operational voodoo is happening. Like it felt better, but it never felt like it really got the full way of where we really wanted it to go, where we kind of wanted to bring everybody together. So I think in that sense, it's good. If you move serverless, I think it's great. You can skip chefing. Well, you probably weren't doing that anyways because you had that container strategy. But so now you can skip Dockering all the things, which is really great for you as well. You can just skip straight ahead 2 jumps. It's very lean startup friendly. It's reduces the cost. It's really nice. You can just put together an idea. You're only paying 100 millisecond increments. You also get a lot of time for free through Amazon and all these services. So in a lot of cases, if you're just kind of developing apps and trying to figure out like what you're doing, like you're paying $0 or $5 or something really, really low kind of during that interim. It lets you go fast. You lower your cycle times. You have faster cadence, less complexity. Your complexity is different now. That's a big problem. I know a lot of people feel like, oh, like automation is going to take our jobs, or people in the media and stuff like say that. And I think us in technology know that that's never really true. Like you're just transferring your complexity to another part of the stack, and you're still having to solve that problem somewhere else. So I think that we see that like operations has to rationalize the model. It's hard to figure out like, okay, like now I have this gateway, and now I have all this proliferation of services, and that makes it difficult to figure out like which functions talk to what. Monitoring, I mentioned earlier, like there's some hooks, but not great. Logging, similarly, like you can hook over to Amazon, or I know some people are pumping stuff out to like their Elk stack, but it's just not as like simple as you would, because like whenever you're running an app in like a web server context, specifically like Nginx kind of has guardrails on like what kind of logs it's going to emit, right? Apache has guardrails, but for some of this stuff, you're having to like craft your application log messages, and anybody who's developing like a custom application that you wrote, and you're like, oh, I never thought about writing a log message for that type of event, right? Anyways, so I think another really good thing for it, another problem for it is like it's actually stateless, kind of. There's another like serverless got you. So what happens here is your function comes in, the API gateway makes a request. You make a request to your API gateway, or somehow you invoke the function through an event. That's a real common way through the web. But Amazon Lambda spins up your container, it handles a request, and then it's supposed to shut down in a certain amount of time. But it'll keep it live. I think it's like 10 seconds or 15 seconds. I can't remember the number off the top of my head. Amazon will keep that kind of warm, so it doesn't have to do that spin up again if another request comes in that short window of time. So you can't really like you can't have anything that's persistent across runs unless you're like putting it back in the database, or you're putting the cookie on the customer, or you're figuring out some other way to handle that data. If you're doing stuff in like the JVM, like I think that's a little bit longer. I think there's a temp scratch base that you can use on the box. So some people are doing this weird, and some people are doing some weird stuff where you're pinging it every like 9 seconds or 10 seconds to like keep that server alive. Amazon will still refresh it every 5 minutes to keep that container alive, but it's really one of those things to just gain performance impact. Like let's say you want to load like something large into memory, or put something on disk in your like scratch area. Anyways, but you kind of really end up having to design for complete statelessness. So, all right, okay, yeah, this is a really interesting thing. Every company I've worked at where we're doing cloud, it's always like use EC2, use S3, don't use anything else, right? It's like because we always have this really romantic idea that we could just leave Amazon whenever we want, and we'll just go over to Azure, right? Or we could go over to some other company, and we'd be able to do it in just hours, and it'd be this really really great experience. I don't know anybody that's actually kind of like made that transition, but you kind of start off with that idea, like I'm not going to get locked into all these third-party services. But by its very nature, this serverless concept really kind of locks you in, right? Because you're starting to use the API gateway to handle stuff. You're starting to use Amazon Lambdas. You're storing stuff. You're using their database services. You're not running any servers anymore, and so you can't really just like rip out and replace into some other provider. All right, that's good. Man, I showed this once and people were like, "What?" And I was like, "This is my favorite slide." So, okay, so this is like the second half of the talk is going to be all about security. So we'll kind of skip through that. Just like this photo where someone has the family photo when someone has their eyes closed, you can't really get like full reliability by depending on a bunch of other actors inside of your services, right? And so you can't get 3 nines when consuming like 99% available services. There's services guarantees and promises. Patrick Dubois did a really good talk on this at Serverless Conf, and it's online last May. This was written by Mark Burgess, who's going to be speaking at the All Day DevOps event. So I don't know if you guys have seen alldaydevops.com, but you should totally sign up. It's a virtualized conference I'm helping work on with Ernest and Derek and Shannon and some others around here. But we have to think about all of these instances are now like having to keep promises between each other. And so I'm not going to like dive into that much because we could spend a long time talking about it. But it's really it really changes your system operational model when you're thinking about how things are. Like you know, in the old days, you used to really worry about like how long a server was up and its performance, and kind of like we had a real clean SLA, well, kind of clean SLA way to calculate that stuff. Okay, so what do people do? What do people do with serverless? Let's kind of move into some more interesting stuff here. People use it for that image resizing thing. That was when Amazon first launched. It was like, yeah, you can make a big picture and a small picture, and you just whenever anything goes in the S3 bucket, your Lambda wakes up and resizes everything out and spits it out the back end. And that was kind of the de facto example. Other things, people look at it for queue processing. In that Martin Fowler article. This is an ad service thing. It doesn't really change much. Kind of a traditional model is up on the top, and in the serverless model, it's down below. But now your Lambdas are, instead of like running as its own server, it's running as all these Lambdas that, as stuff comes across the channel, it's taking action on them. You can do stuff like run a web application because now you have Amazon's CloudFront and their you can host static sites out of S3, and then you run the API gateway to return any logic. You have you can do all this cool stuff. Here's the API gateway, which sort of breaks down like kind of visual for what we talked about earlier. It's like you call the cats, and it goes to the cats function. You call the dogs, goes to the dog function. Also, like there's a project called LambCI that built a whole CI system built in Lambda, which I think is pretty cool. Like that came out this summer, and I was like, now we're starting to think of more innovative things. It doesn't sound like really like cute workloads anymore, right? That sounds like real, actual stuff that you would want to be doing. I have a friend who does all their licensing stuff using Lambdas. It's event-driven, highly available, really performant, but it's not core to their actual product, so they're kind of move that out over there. I think that we're all here because we care about security, right? Or to some extent, we're interested in the topic. So let's talk about what you normally see. So it's not a requirement, but it's a de facto. Like everything's speaking HTTPS. But we have this problem now that like what used to be system calls local on a box, now they're distributed. Distributed computing has pushed them out over the entire network speaking HTTP, right? Serverless shifts the attack surfaces to third parties. And so those are kind of some downfalls that I see of the serverless problem. Also, I want to mention, I don't think I have another slide on this, but like if you can get somebody's serverless application to like work for the 5 minute, you have to run in a full 5 minutes, but you can get the serverless application to kind of like stall out and run for 5 minutes, and you can flood all their channels and run 1,000 Lambdas for 5 minutes each and keep doing that. Like you're basically going to run up their Amazon bill, to a really huge amount. So that's an attack vector. The infinite loop problem is expensive in this, so it does put some prioritization on testing. So, all right, let's try a sample application in Lambda, and I'll show you kind of how I built this. And there's some GitHub links if you want to take a look at it more. So all the techno hipsters use Golang, unless you use Rust, which you're even more techno hipster than the Golang folks. That was one of my other jokes, so sorry guys. But Lambda supports Java, Python, Node, and a bunch of JVM stuff. You can bring your own binary to the party, which is kind of how the Go stuff functions. And so Go Sparta lets you bring Golang, but with a Node.js wrapper. There's other ones that use Python wrappers. And so let's see. This is all the stuff that. Now here, I should mention too. Like Go Sparta is like a framework, but it's not just writing the Lambda. It's also helping you do your API gateways and tie into the other services that Amazon provides. So it kind of puts it all together in one nice package for you. The actual Lambda itself is just kind of a Node.js shim that runs across to your Go compiled binary. All right, what kind of event sources can you hook into? This is this long list here that I just kind of mentioned. It's like pulling in from all these options, or all these services. And there's other options for how to do this, right? There's Serverless, Apex, Kappa. I built a little application called Wordy. It analyzes textual occurrences given a block of text, returns a JSON for the count of words. There's no visualization on it. I'm sorry, I just returned a big block of JSON here for you. But you'll have to use your imagination. So, it calls an API under the hood to get the text, and then it's comprised of Lambda, Amazon S3, and an API gateway. Here's kind of a wrapper. This is the event that actually calls. You can see there's this handler where it is calling Sparta there, and there's some context, but it's returning. It's returning to the very last line. It says printf the word weight text. So it's calling back into the application to return that on the call. Let's see. This might be a little harder to see here, but this Lambda function. This is kind of like your startup stuff, right? You're saying, all right, I want under this resource wordy/test. That's going to be the API gateway, and the stuff that I'm going to accept are GET requests. In your main part of your Go function that is wrapped with all this Lambda stuff, or wrapped with all the Sparta stuff, you're telling it like what the name of my my Lambda function is, what API gateway I'm using. I set some profile type stuff, but then you're just kind of calling this. I guess you can't see my mouse up there, but you're just calling the application, and you're kind of giving it some stubs there. Because API gateway is kind of the main focus for a lot of this stuff, people are building web apps with it. That's kind of you're feeding all those into it when you instantiate it. Anyway, so when you first start with Sparta, then you have to say, I've written my application, I've written my Go code, I have unit testing on all that, and then I kind of write this wrapper function around it that tells it like what's what, right? Like what's my gateway, what's my where my code lives. You run this go run provision, and it hooks it out to the right S3 bucket and puts everything in place that it needs to. And then I have some bad news. I was trying to do this because I was like, well, I want to see like how do we do this with security in mind. And I started out really good. I was like, I'm going to make some sweet IAM rules, which is the Amazon restrictions for like what resources are allowed to access. And so I was like, okay, CloudFormation, read only or just limited right to certain resources. And I started down that. And then I started getting tons of errors, right? And Sparta kept telling me like, can't do this, and I couldn't figure out what was going on. And so I was just like, yeah, you get full access, right? And so I think that's one of the problems that a lot of developers will face when kind of doing this stuff, because it's not super clean to figure this out. The documentation's still kind of coming out. A lot of the frameworks don't always give you the right error codes or messages. And so as a security professional, like it's really important to be kind of looking at like the policies that are actually happening behind the scenes, because Amazon has it so you can have more discrete type stuff that you don't see the names here, but I actually have these like scripted policies that are limiting to the right ARN resources. But here I'm just using the default stock ones because I'm like, just give me full admin access because I want to make that happen. So I felt a little bad about it, but I wanted to get all working. So here we are. Well, once you're done, you upload it. Amazon inside of the Lambda, they have a Lambda page, which is pretty much about as useful as all the Amazon UI stuff. It's difficult to navigate, but we all live with it because of what they provide us. But you go in here, you see your application, you see that it got loaded up. Here, you can also test right from the console. So this is I believe this is the,
Okay, yeah, so this is the first request. It ran in 343 milliseconds. I was billed for 400 milliseconds, and then I hit test again real quick, and it was actually able to execute in 84.78 milliseconds. So you kind of see there's that startup time for the container, the container that's running your service, and then then it keeps it alive so it can handle another request as it comes in. Let's see. Then now you got to set up an API gateway, which we did inside of our Sparta code, but now we're looking at it again here. This is the method request coming in, so you can click that little test lightning bolt over there, and it'll run the whole gamut. And you can say you got to have certain authorization. You can hook all sorts of pieces together with that. But it's pretty nice because it shows you kind of a flow of how your request gets handled. And let's see, you can also test, so you can test your Lambda in the console, and you can also test your API gateway in the console. And I get back that lovely block of text there. And then I'm doing the same thing here as well, and now I'm in a browser and just kind of testing it as well. Over time, I learned that, or first I was like, oh, this is great. I get like little graphs. I can see how long my response time is, and how long it actually took like the code to run versus the container to run, or the Lambda to spin up and run. And then I was like, man, there's a lot of holes here. Then I was like, oh yeah, it's not running. We're always used to those lines that are always going across the whole screen, but the application itself just goes away and then it comes back. And so that was kind of a thing that I learned. So, okay, so what did I learn about security, especially in serverless? And so I'd like to thank my mom for posting that photo on the internet. It's really been great for me. So there's 4 areas we talked about earlier. It's the secure software supply chain, delivery pipeline, data flow security, attack detection. Shannon talked about this earlier. This is from Shannon's deck, but we got to think about our software supply chain. As I was building it out, I was like, okay, yeah, we really I'm going to be inheriting all the stuff from Sparta and all the libraries that it brings in, but I am sort of still stuck with all the business that I get from the container that is getting run and executing the Lambda function. But Amazon kind of manages that, so I really don't have any control over it, which in some ways is kind of nice because I know even with container infrastructures, you kind of keep using this old piece of old containers laying around, and you're not updating it, and you're still kind of stuck with some of that OS problem. So we get some surface area reduction because we're not actually caring about what versions of Python or whatever. All that's kind of pushed off onto the provider. And it also, because you're using containers and in a really specified opinionated containers, and you're not doing these virtualized instances, you don't get to bring your old busted OS, which is really good, right? You're not gonna have some crazy fire drill for OpenSSL or shell shock or all that other OS junk that's hit us over the last couple of years. But now we have this other problem. We talked about, now we're taking all these internal calls and all that stuff, and we're expanding them across the network. We have to start thinking of all of those services as a part of our supply chain. Okay, yeah, stuff you gotta worry about SSL and TLS everywhere. Of course, we know DNS is always a problem. This kind of is a real simple stack of it's sad this simple, but this is what you would be putting together for running an application, right? You have your function, your storage, your queuing service, you have your auth service, all that stuff. And you end up really needing something to do third-party service for config changes, stuff like Evident.io or ThreatStack or Alien Vault. You're looking at those companies to say, what's changing inside of my what's changing inside of my Amazon console? Looking at all either your logs or access attempts and all that stuff. So configuration kind of shifts from OS configuration to cloud provider configuration. You also have to do all that access control stuff that I mentioned earlier that I kind of just cheated on, right? It's like all the IAM roles, least privilege, all that kind of business. It's always real tempting to skate by this stuff, but that's the stuff that ends up biting you kind of in this new landscape. All right, next area, we're going to talk about the pipelines. So I sort of think of supply chain like not the full thing. I know you could really think of it all the way out to your customer, but that's all the stuff that was being built in. So, but now you're writing like, how do you test it, right? Because we're living more and more in a culture where we're just like encouraged to just ship it, and all of our companies are wanting to do that. But it really begs the question, like, how do you do unit testing? Unit testing in serverless is pretty good because it's just functions and code. And so all the pieces of my stuff that's just Go code, like it was fine. Like I could do unit testing on that. You do static analysis just like you used to, but we know like unit tests like get written a lot, right? All right. Okay, there we go. All right. Integration testing. Now this is like where you can put a lot of your security testing, and this is actually a real problem with serverless because you can only test so much in kind of your local dev area, right? You can stub out some of the values, but you're so dependent on other third-party services that you really need to like integrate across all those things. Now, nice part about all this is even though we made that move from data center to cloud, like a lot of us kind of cheaped out still kind of in our developments, testing, staging environments. It didn't like completely make them mirror images of production because people still were worried about that. The great part in serverless is like there's no reason not to, right? It's all code and you just give it a new name and you're off to the races. So you do actually have a pre-production environment to testing, staging, whatever that you want, that you can actually assert that it actually mirrors production. So you got to think of configuration as part of your delivery, and most of the frameworks do this, like Kappa or Sparta. But let's say you're just using kind of a point solution, or you're just writing your lambdas, kind of uploading through the API. You'll have to do something different to keep track of all that. Traditional like cloud security 101 stuff still applies, right? Provider security, like root access keys, user profiles, securing the keys in the dev system, using the multi-factor auth. So you can do like some simple deploy to pipeline security stuff. So like only devs can push to development. Only build and deploy systems can push to like the pre-production environment. Your integration tests must pass in this environment. Security validation must take place, and then allow only your push to prod like by your deployment system. So the stuff that I've built at Signal Sciences that manages a lot of our deploy infrastructure, it does this kind of this exact thing. Of course, you have other requirements, and everybody's build pipeline and deploy pipeline looks different, but you want to be thinking about that. So security integration testing, I work on a project called Gauntlet. A lot of people, I've talked about it here at LASCON before. And we've done some training on this. Matt Johansson and I did this last year at South by Southwest. So if you're interested in it, check it out. It's a couple hundred slides with like workthroughs and examples of how to do that. You're still stuck thinking, so I think another layer is like the data flow security. It's really important, like Shannon this morning was talking about attack maps. I think kind of pulling out data flow diagrams and understanding like where do all the pieces fit, and kind of either do data flow diagrams, attack maps, threat modeling, whatever you want to call it, but you need to be thinking through all the third-party services that you're accumulating here. You have other problems where you can have application layer denial of service. So if you have big spikes, or you have a limit to 1,000 concurrent lambdas, you can get that upped, but we mentioned that earlier. You have timeouts, execution restrictions. Let's see, what else do we want to talk about? We talked about HTTP. Okay, and the last thing I think that we want to talk about is attack detection. So I think in development, we're still using kind of similar like OWASP type tooling, right? Language filtering and all that stuff. But I think AppSec problems actually become a lot more interesting in the serverless world, especially stuff where we're looking at SQL injection, cross-site scripting, all the traditional stuff that we looked at before, because now you have now it's maybe not as much kind of a front-end web app, but you're like seeing all the REST APIs. I mean, everything's talking HTTP in this new world, so I think that even puts more emphasis on why AppSec needs to be playing ball with this. So how do you defend against it, right? So you can log and emit events. There is a application called Vandium, which is a light SQL injection wrapper that you can put in serverless. That's kind of their claim to fame right now. You can implement CSP, but honestly, like I don't have a really good answer for you on a lot of this stuff because we just don't have any solutions that are running out right now. All right, so this is my conclusion, which I gave at the beginning. We'll do it one more time. So serverless encourages functions as deploy units. You couple that with third-party services and allow running end-to-end applications without worrying about system operations. A lot of the patterns that we're seeing, they're just emerging. Some of them are becoming more and more interesting, and we're seeing a lot of similar things to how people are using cloud back in the, or virtualization to cloud to containers and serverless. Serverless is easier. Serverless is also harder in regards to security. And there's 4 key areas: software supply chain, delivery pipeline, data flow security, and attack detection. I think when you start kind of breaking down your serverless architecture and your kind of plans forward, you want to be thinking about those 4 key areas. All right, so that is 125 slides, and this is slide 126. And just want to say thanks, and grab me if you want to talk, and thank you.